This is once again your Sir John Silibio, your senior high school physics teacher from Iloilo City National High School. Okay, so we will consider our discussion based on the most essential learning competencies that is expected by DepEd for us to cover. Okay, so it's expected that once again, based on our content standard, we'll still focus on the effect of instruments that are used in measurements, the uncertainties and deviations in measurement, as well as the sources and types of error. This is the content standard that we are trying to focus, but specifically, this is the most essential learning competencies that we are trying to cover. Okay, last time the video was created that's focused on specific topic. This is that is conversion of units, and this time we will try to deal with the expression of measurements in scientific notation. Okay, so this is the code once again of the topic that we are trying to cover. Okay, so once again, still we are on measurement, but this time we are very specific. We are dealing with the significant figures and scientific notation. Okay, so significant figures. So to accurately express numbers in scientific notation, it is important to determine the number of significant figures. That's why we need to introduce this first so that it would be very easy for us to deal later on with scientific notation. Okay, and for forming calculations, the final answer should be expressed considering the rules of significant figures. That's why oftentimes when we conduct examinations, most students would ask if how many significant figures should be carried out in expressing their final answer. So the answer will be based on the number of significant figures or on the rules involving the number of significant figures. Okay, so I have here with me some rules in determining the number of significant figures. So the first rule, all non-zero digits are significant figures. Okay, so for example, we have 1, 2, 3, 4, 5. Okay, so this indicates that all of these non-zero digits are significant. So in this case, there are 5 significant figures. All of them are significant figures. Next, we have 1, 3, 4, 5, 6, 7. So there are 6 significant figures. All of these numbers are considered to be significant. Okay. Next, rule number 2, all zeros between any two non-zero digits are significant. So this is irrespective of the placement of the decimal point. Okay, so for example, we have 10,002. All of the zeros that are between two non-zero digits 1 and 2 are significant. So in this case, there are 5 significant figures. Okay, another example is we have 200,001. 0.0101. Okay, so in this case, you will notice that there is a decimal point, but there are zeros in between non-zero digits. So considering that 2 and 1, that there are zeros in between them, and there is a decimal point. So irrespective of this, all zeros in between these non-zero digits are significant. So in this case, there are 9 significant figures. All of the zeros are significant. Okay, rule number 3. In rule number 3, if the value is less than 1, so of course we're dealing with small numbers, then zeros between decimal point and first non-zero digit are not significant. So in this case, this is the decimal point, this is our first non-zero digit, these zeros are not significant. So in this case, there are only 2 significant figures. Another example is we have this 0.000213. So in this case, this is the decimal point and this is the first non-zero digit. So that simply implies that these 3 zeros are not significant. So there are only 3 significant figures, and these are 2, 1, and 3. Okay, that's our rule number 3. Okay, next, rule number 4. Rule number 4 tells us that the trailing zeros in a non-decimal number are not treated as significant numbers. So you will notice 10. There is no indicator of the presence of the decimal point. There is no dot here. The same is true with here, and the same is true with here. Okay, so it simply implies that only 1 is the significant figure because there's no decimal point. Okay, you'll notice also on 100, even though there are 3 digits here, but only 1 is the significant figure. In this case, there are only 2 significant figures. So trailing zeros in a non-decimal number, there are no decimal point indicated here. No, so therefore the trailing zeros are not significant numbers. Okay, next rule, rule number 5. Trailing zeros in a decimal number are significant. So there is a presence of a decimal point, therefore all trailing zeros are significant. So in this case, there are 5 significant figures here in this case. These are trailing zeros after the decimal point. So we have 10.010 indicates that there are 5 significant figures. Okay, these zeros become significant because of the presence of the decimal point. Example, we have 5.00. All of the zeros become significant because of the decimal point. In the absence of this, then there's only 1. But with the presence of the decimal point, these zeros become significant. So there are 3 significant figures in this case. Okay, that's rule number 5. Next, rule number 6. The presence of a special character like bar or asterisk may indicate that zeros are significant. So if there's a bar in this case, the zeros become significant. Okay, another special character, asterisk, indicates that these zeros are significant. So there are 6 significant figures. But this case rarely happen probably. However, there are instances wherein this bar are placed in certain number or certain cases. In the last rule, rule number 7, if we wish to accurately express the desired number of significant figure, then we have it in a form of a scientific notation. So you will notice it as a form m times 10 to the power of n. Okay, wherein this m corresponds to the significant figures. If we wish to have only one significant figure, then we have this 1. These are numbers of significant figure, and this indicates that there is only one in it. Like another example, we have 1.0 indicates that there are 2 significant figures. This 1 and 0 are significant figures. This is another way of expressing 1 times 10 to the power of 8. They are the same, having the same value, but having different number of significant figures. This is an example wherein it has 2 significant figures. This is the same number raised to the power of 8. However, this given has 3 significant figures. So scientific notation, once again, is the best way if we wish to express number to have 1, 2, 3, or 4, or any number of significant figures. So the best way is to express that using scientific notation. Okay, those are rules in determining the number of significant figures. Next, this is very important, the rules considered in determining the number of significant figures and the process of rounding off that we are doing when we perform operations like addition, subtraction, multiplication, and division. Okay, so the rule on addition and subtraction are as follows. So of course, when we subtract, we will obtain the difference. If we add, then we are getting the sum. So this final answer should be expressed following a given having the least number of significant figures after the decimal place. So if we add or subtract, we always consider the number of significant figure after the decimal place. So in this example, we have 45.550. After the decimal place, these are significant figures. There are 3 of them. Okay, next, after the decimal place, there's only 1. Okay, therefore the final answer, according to our rule, should carry with it a final answer with 1 significant figure after the decimal place. Okay, so if we perform it, adding this will be the result, 55.650. This, however, is the tentative answer, but the final answer should be 55.7. Okay, because the number to be dropped here is 5. And of course, this rule it's what we call rounding off, wherein if the number to be dropped is 5 or greater, then we add 1 to the preceding number, which is 6, to have only answer with an answer, with one significant figure after the decimal place or the decimal point. Okay, so the final answer will be 55.7. Okay, so if there is only one significant figure after the decimal place, similar to the given. Notice also that the number to be dropped in the example once again is 5. We have a rule, and you can confirm that using your Microsoft Excel or any calculators, that once we drop a number which is 5 or greater, it indicates that we will add 1 to the preceding number, and this process is what we call rounding off. Okay, so we drop 5 and add 1, so we have 55.7. That's how we perform or determine the number of significant figure and express our final answer. Okay, another example is in subtraction. If we subtract this value, we have 45.550, you will notice that there are 3 significant figures after the decimal place. However, we've subtracted that with 10.11, so this value has 2 significant figure after the decimal point. So 1 and 1, there are 2. Therefore, our final answer should carry with it 2 significant figure after the decimal point. So if we have 35.440, we should drop 0. So this is considered to be the tentative answer, but the final answer should carry with it only 2 significant figures after the decimal point, similar to the given with the least number of significant figure after the decimal place. Okay, so the final answer will have 2 significant figure after the decimal place. We have 4 and 4. The 0 was removed. Notice also in that case that the number to be dropped here is 0, and therefore we retain the value of the preceding number, which is 4. We are not adding. This is still a process called rounding off, where we add 1 to the preceding number if the number to be dropped is 5 or greater, but in this case it's 0. So that's it. That's the rule in adding or subtracting numbers considering the number of significant figures. I hope you will practice and consider this in expressing your final answers in the future examinations. Okay, these are also another case when we multiply or divide. So the result of multiplication, of course, is product, and the result of division is, of course, the quotient. So we should express our final answers in such a way that we consider the given with the least number of significant figures. So for example, in this case, okay, when we multiply, we have, for example, 45.26. You will notice that there are 4 significant figures. All of them are significant, and we multiply that with 10.1. 10.1 has 3 significant figures. If we use our calculators, you will notice that this answer was obtained or will be obtained. So 457.126, this is the tentative answer, but of course the final answer should carry with it a number of significant figures, which is 3. Okay, so therefore we should eliminate 1, 2, and 6, leaving only 4, 5, and 7. Notice that the number to be dropped is 1, to have a final answer having 3 significant figures. Okay, so 457 will be our final answer. The final answer will have 3 significant figures, considering that the given 10.1 has only 3 significant figures. If you will recall once again, the given 10.1 has 3 significant figures. Okay, that's the reason why. Okay, notice also that the number to be dropped is 1 on this case. And our final answer, number to be dropped is 1. Therefore, we retain the value of the preceding number, and this process once again is called rounding off. We only add if it is 5 or greater. However, it's less than 5, it's 1. Therefore, we just simply retain the value of the preceding number, which is 7, leaving us with a final answer 457. Okay, so that's the example in multiplication. Another example in division. Supposing we need to divide this. 245.26, you will notice that there are 5 significant figures in this case. If we divide that with 11, there are only 2 significant figures. Therefore, the final answer should carry with it only 2 significant figures. It should leave us with only 22. Okay, therefore we need to drop the rest, no, and the number to be dropped is 2. So how do we express our final answer? So the final answer should have only 2 significant figures, considering that the given with the least number of significant figure is 11. It has only 2 significant figures. Notice also that the number to be dropped is 2 in this case. Therefore, we retain the value of the preceding number, and once again we are still rounding off. We only add if the number to be dropped is 5 or greater, but in this case this is 2, therefore we retain the value of the preceding number and leaving us with a final answer 22. Okay, I hope it's clear to you how to express your final answer considering the number of significant figures. Okay. The next topic that we'll be dealing with is scientific notation. So as what we have mentioned in rule number 7, scientific notation is one of the accurate way also of expressing our final answer to have a certain number of significant figures. So it's a shorthand way or an efficient way of expressing a very big or a very small number. So that's scientific notation. So this is the form of scientific notation. So this is its standard form, m times 10 to the power of n, wherein this m corresponds to significant figures. Okay, and n denotes power. So m refers to the significant figures that we presented a while ago, multiplied to a base 10 that is raised to certain power n. Okay, so that's it. The most accurate way of writing scientific notation is to express that in such a way that the decimal point is usually placed after writing the first non-zero digit. So that is where the decimal point should always be located in trying to express the correct number of the correct way of expressing number in scientific notation. Okay, having a positive power, the exponent n is decreasing when it is moved from left to right and is increasing when moved from right to left. So the value of n, the absolute value of n, if it has a positive power, will be decreasing when moved from left to right. It simply means from this point up to this point. If the decimal point is moved towards this direction, then it is decreasing. Okay, however, if it is moved from right to left, okay, from here to here, then eventually decreases. So say for example, we have 550.0 times 10 to the power of 5. So it could also be expressed as 0.55 times 10 to the power of 8. Notice the power. And if we move from this point towards this point, we are moving from right to left in this case. So if we are moving from right to left, we are expected to have an increased value of n. So look at n. From 5, we move 3 places, 6, 7, 8. So the decimal point rests here. Therefore, the power n was changed to 8. Okay, notice also that the movement of decimal point here in this example is from right to left. Therefore, the value of n increases. Okay. In addition, 550.0 times 10 to the power of 5 could also be expressed as, so in this case, it moved from left to right. So you will notice this decimal point is here. It moved 2 points, 1, 2. Okay, notice the value of n. Okay, the value of n decreases from 5, now it becomes 3. So this value is equal to this. It's equal to 55,000 times 10 to the power of 3. When the movement of the decimal point is from here, from left to right. Okay, like this. However, 550 times 10 to the power of 5 should be expressed in standard form. As what we have mentioned, the decimal point is usually placed after writing the first non-zero digit, like in this case. So it should be moved, writing that after the first non-zero digit. So it's understood that the decimal point is located here. So we have to move 1, 2. So we add 2, then therefore the power is 7. This is the standard form of expressing 550.0 times 10 to the power of 5. So it should be 5.50 times 10 to the power of 7. Okay, so that's it. That's how we express numbers in scientific notation. Okay. Having a negative power, the exponent n is increasing in negative value when it is moved from left to right and decreasing in negative value when moved from right to left. Okay, let's consider for example. So if we have 0.05 times 10 to the power of negative 8, we could express this also to have a value which is 50 times 10 to the power of negative 11. So you will notice that the movement is from this point, it's moved 9, 10, 11. So it increases in its negative value because it's moving from left to right. So it increases in negative value. From negative 8, it becomes negative 11. Because it moved from left to right. So left to right. Okay, so it moved 9, 10, 11. Okay, so the decimal point is here already. So it's added. Okay, because of the movement, the power negative 8, as what you have noticed, becomes negative 11. Okay, I hope that you could consider this, and you could also practice this at home. Okay, furthermore, the same value 0.05 times 10 to the power of 8 could also be expressed as, supposing it moved on the other side. So from here it moved two decimal places. Okay, so we have here, so instead of negative 8, the negative value decreases. So as what we have mentioned, negative value decreases when it is moved from right to left. So from right moving to left, we add 2 decimal places, then negative 8 becomes negative 6. Okay, notice that the movement of the decimal point is from right to left, therefore the power n, which is negative 8, is decreased into negative value, wherein the n now becomes negative 6, as what you've seen. However, as what we have mentioned, according to a rule, it's very important to express number in such a way that the decimal point should always be placed after the first non-zero digit. So in standard form, the answer should be 5 times 10. So we have to move the decimal point here, okay, to the power of negative 10. Okay, so that's the implication, that because we are moving towards this direction from the left to right, therefore the negative value increases. We're moving 2 points or 2 decimal places, therefore it becomes negative 10. So this is the final answer, 5 times 10 to the power of negative 10. Okay, so I hope that you'll try to review and consider writing some examples and expressing them to have a correct number of, or a standard form of numbers expressed in scientific notation. Okay, so anyway, if you have any questions, you can just shoot them on our Google Classroom, in our stream, then probably we can discuss that to deal with difficulties that you have encountered. Okay, so operation involving powers. How do we add or subtract numbers expressed in scientific notation? So to perform addition or subtraction of numbers expressed in scientific notation, so we should ensure that both of them have the same power or exponent n. So this is very important for us to perform addition or subtraction of numbers expressed in scientific notation. We must see to it that they have the same power or exponent n. Okay, so this is our addition rule. So we should make sure that n1 and 2 are the same. We call that as n1 and 2 common or the same exponent. So that's the only time wherein we can add m1 and m2. That is, if m1 and 2 is n1 2 is the common exponent of the two given values expressed in scientific notation. Okay, so for example, we have here 1 times 10 to the power of 5 plus 2 times 10 to the power of 6. So according to our rule, we must see to it that they have common exponent. So we could either move on this direction, we simply adjust this in order to have power 6 from 5 becomes 6. If we move the decimal point towards this direction, we increase the power now becomes 6. The common power is 6. That's the time wherein we can add the two given values expressed in scientific notation. Therefore, the final answer will be 2 plus 0.1. This will give us 2.1. We add the m's and we copy the base raised to the common power, which is 6. So notice the common power here is 6. That's how we add. Alternatively, when we manipulate on this part, then we can have an exponent which is 5. So like in this case, we manipulate on this part, therefore from 2 it becomes 20. However, the power was changed to 5, having a common power which is 5. So the final answer will carry with it 221, because we have 20 plus 1. These are the m's. Copy the base times 10 to the power of common power is 5. However, once again, the final answer should be expressed in such a way that the decimal point is placed after the first non-zero digit. We really have to move. Therefore, this should be the standard form. It should be expressed in such a way that the final answer will have a form in which the decimal point is placed after the first non-zero digit. So this is the final answer in addition. Okay. Next, how about in subtraction? If we add or subtract, still the same principle is considered. m1 times 10 to the power of n1 minus m2 times 10 to the power of n2, n sub 2. Okay, this is the second exponent. So we can subtract the m's, copy the common base and the common n, where n12 in this case is the common exponent of the two given. Okay. So say for example, we have 4 times 10 to the power of 7 minus 2 times 10 to the power of 5. So you will notice here that we can maneuver or manipulate this in such a way that it will have an exponent 5. That's the only way for us to combine if they have common power. So to do that, we need to express this 4 to become 400 so that it will be raised to a power 5 to have a uniform n. So by this time, if we have 400 minus 2, this will give us 288 times 10 to the power of 5. Notice that the common power is 5 in this case. However, we express our final answer in such a way that we move the decimal point after the first non-zero digit. Therefore, we need to add 2, then we have 7. So where the decimal point is placed after the first non-zero digit. Okay, that's the pattern and the rule. Alternatively, you will notice also that instead of manipulating on this side, we will manipulate on this side. Okay, we would like to have uniform power, so we could manipulate this in such a way that it will become 0.02 times 10 to the power of negative 7. Notice that we move the decimal point by 2 places, 2 and 0. So we have here. Okay, having uniform power, we can now perform subtraction. 4 minus 0.02, we have 3.88 times 10 to the power of 7. They have common power. and this is similar to what we have obtained, okay, in performing subtraction, in considering this scientific notation. Okay, so I hope that you will also practice at home, and you could pause, change the values, and perform also the operations to master it. I encourage you to repeat the process and try to master it. Okay, multiplication rule. If two numbers are expressed in scientific notation, we multiply the m's multiplied to a base 10, having a power where we add the n's. So this is the general form. If we have a number expressed in scientific notation, another one in scientific notation also, then we need to consider this rule. We multiply the m's, copy the base 10, and we add the n's. Okay, for example here, we have this one, 1 times 10 to the power of 5. So m1 is 1. We have the base 10, and our n1 here in this case is 5. We multiply that with another number expressed in scientific notation. We have 2 times 10 to the power of 7. This is our m2. This is the common base, and this is our n2, which is 7. So this is the format. So you will notice that as our rule, we multiply the m's. So we have 1 times 2. These are m's, m1 and m2. Of course, the result is 2. We copy the common base and we add the power. We have 5 plus 7. This will result to positive 12. So this is now our final answer. We have 2 times 10 to the power of 12. Okay, that's how simple it is. In division, so we consider the rule. We divide numbers expressed in scientific notation. So to do that, we divide the m's. We have m1 divided by m2. Multiplied to base 10, having a power where we subtract n1 to n2. So these are n1, the exponent, the upper one, and the n2 is the exponent of the second value expressed in scientific notation. So this is the general format. Continue, we have now, for example, we have 8 divided by 4. 8 times 10 to the power of 8 divided by 4 times 10 to the power of 4. Of course, we divide the m's, m1 divided by m2, 8 divided by 4, this will give us 2. We copy the common base, and then we subtract 8 minus 4, this will give us 4. Okay, as a result, of course, that's the final answer. That's the general form, and of course, expect that I'll be making some worksheets for you later on to work on, where you need to express this in scientific notation, and alternatively you will express the other one and perform one. So once again, credits to the following. Okay, and the end. So I hope you have learned, and hope to see you on the next videos.